Hi, guys. So I'm kind of covering up some zits over here. But anyways, I wanted to read to you something that is in our solar system scale notebook. It's called A Brief History of Measurement. And I want you to listen as I read it to you, and you can read along. And I might add a little bit of tidbits to it. And then you're going to answer the questions below. Okay? So, to measure a distance between two objects, you need two things. You need a unit of measurement, how much you are measuring by, and a tool, what you measure with. Long before measuring tools like rulers and tape measures were common, people needed a way to measure things. In early times, people who did not have tools used parts of their bodies, like their thumbs. About 950 years ago, the width of a person's thumb was considered an inch. In many languages, the word for thumb and inch are the same or very close. A person's foot was used to measure feet. A yard was the length from the tips of the king's nose to the tips of their fingertips. Everyone had a way to measure distances, but there was a problem. Everyone knew what to measure with, but there was no standard for how big things were. For example, if you measured the length of your bedroom with your feet, and then your friend did the same thing with their feet, you would not get the same exact measurement because our feet are different sizes. Eventually, people agreed on standards, measurements that were the same for everyone. The Romans liked to divide things into units of 12. This is why we have 12 months of the year. They decided that a foot contained 12 inches. In England in the 1100s, King Henry I decided to use the Roman standard of measurement for feet, and he spread the word to his people that a foot was 12 inches long. Once the standards were set and everyone agreed on the lengths of units of measurement, the system worked better, but it still wasn't perfect. In the 1800s, the French Academy of Sciences were asked to develop a system of measurement that was based on scientific measurements and used the base 10 system. The Academy set their standard of measurement, a meter, as a fraction of the distance from the North Pole on our Earth to the equator, which is the center of our Earth, as we've talked about in science. Larger and smaller units were made by multiplying or dividing a meter by factors of 10. 1,000 meters is a kilometer, 100 centimeters is a meter, 10 millimeters is a centimeter. Even the name of the units indicate how big they are. Kilo means 1,000. Centi means 100. Now we can just move the decimal point to change from larger to smaller units. By the year 1900, 35 countries decided that this metric system would be the standard. This is what everyone would use. Some countries, though, like the USA, they did not decide that the metric system would be their standard system of measurement. This could be a challenge because we're one of the few countries that doesn't use that as our standard. While kilometers are useful for measuring distances on Earth, they're just way too small to measure distances through the solar system. For example, the distance from the Sun to Jupiter is 778 million kilometers. Scientists decided to create a new unit of measurement, which would be helpful when measuring the solar system. They called the average distance between the center of the Earth and the center of the Sun 1 astronomical unit. Remember that word as we did our data sheet last week? See right here? AU, astronomical unit. That is the distance from the middle of the Sun to the middle of the Earth. The distance is 150 million kilometers, which is roughly the number of kilometers between the center of the Earth and the center of the Sun. The rest of the solar system ranges between 4/10 AU from Mercury to the Sun to 39 3/10 AU from Pluto to the Sun. When leaving the solar system and looking at other star systems, the AU is still too small for students' needs. So they created a larger unit of measurement. Scientists measure a light year as the distance light can travel in 1 year. The next closest star to Earth, after the Sun, is Alpha Centauri, which is 4 3400 light years away. This means that the light that we see from Alpha Centauri at night, it's gone. It left that star 4 3400 years ago. Our system of measurement has evolved from using thumbs and feet to using the distance traveled by light in 1 year. As our scope of the universe continues to expand, so will our need for new standards of measurement. Now you're going to complete the questions below, and so so I can see what you can do. All right.